Hello, hello.
Hello.
Yeah, good evening. Let's have a look of Lab 7. But before we have a look of the Lab 7, there is a reschedule for next week online session. So the lab for next week will move from Wednesday to Thursday. Please note that. And I'm sorry for the inconvenience. So let's have a look of the Lab 7. This one is about the LoRa stuff. So what's the LoRa at first? The LoRa is a kind of like long distance transmission technology. So it's longer than Wi-Fi and it requires very low energy to sustain. So it's very suitable for the IoT stuff. If you have a look of the lecture slides, you can see there will be a sender side and a receiver side, like this in the figures. So in the sender side, it will modulate the data and encode the data, and then it will become a kind of signal, and we can send it out. And in the receiver side, it will receive the signal, and then it can decode and demodulate and finally get the data itself. So in the task 1, we are going to install this simulator in MATLAB, and then we are going to try to generate a new message with this simulator. So let's just install the simulator here. You can click the link in the specification, and then there is a library. All you need to do is download this one. So download the zip. And then open this one in the MATLAB. So I open my MATLAB and it is in here. So I unzip the file. And then here are the codes. Let me close them all at first so you know who I am, so you know which file I shall open. So this one is the main file, LoRa-phy.m. This one is the main library file. You can go through it, but yeah, just some function inside. So we can use it to generate the messages and decode the messages, etc. And we have some example code inside the example folder. Then we will have a look of it later. So the first thing I want to do in here is to right click this folder like this, and then I add to path. So this one will allow me to use the function in the command window that we need to use it later. So just right click it and then select folder and add it to path. So this is the first step. And after you add it into path, you can see everything that the color change. It used to be a little bit transparent, but now it's like become solid color in here, which means we have already added this one into our path. So that's the first step. And then we can try to play around with this stuff. So in the example, yeah, we can go use the which one is that? Save the signal to file. Yeah, this script. So you can go through this script. basically, the first part is about the configuration. You can try to change the this spreading factor, try to change to another value, and try to change this kind of stuff. And then here is the data itself. So we are going to send an array 1, 2, 3, 4, 5 in the message to the other side. So we will generate the LoRa signal of this data. So let's try to run this script and see what you get. There only one difference in my code is this line. So I add this line at the end of this script. So in your file, you cannot find this line, so you can add it by yourself. If I delete it and then run it, you can see some outputs, encode symbols, and then it will generate a new file in here, which is the signal file, like this. But we want to have a look of the spectrogram, right? So we need to add one more line at the end. So this one will call the spectrogram function in the library. So it can draw the library. You can draw the spectrogram of this signal. So let's run this one again. Then you will have an output come with the MATLAB window. So here is the output of this one. So in task 1, we generate a spectrogram of the array 1, 2, 3, 4, 5, right? So this is the data 1, 2, 3, 4, 5 inside. So when the receiver receives this kind of signal, it can process and then extract the data inside, which is 1, 2, 3, 4, 5. So this is the task 1, how to generate the signals. And then we come to the second part of task 1. So we already have this spectrogram. Then we need to specify which part inside the spectrogram is the preamble and which part is SFD, star frame delimiter, and which part is the data. So which part it represent 1, 2, 3, 4, 5 in this spectrogram. So it's pretty simple and straightforward. So what do we need to have this preamble and star frame delimiter? So that's the first question. And the answer is pretty easy and straightforward because the receiver side will keep receiving signals from outside, right? Because we don't know who and when will send this information to us, send a message to us. So we have to keep receiving the information from outside. But how can we identify this one is a message and that one is not? Because we will keep receiving the signal like this. So it's the first problem for the receiver side is how to identify the start of a message. So that's the reason we need to use the preamble and star frame delimiter. It will identify the start of the message. So let's have a look. What is the which part is the preamble? The preamble should be always like that. It's a kind of and the second thing is the SFD, star frame delimiter, will have totally different shape than preamble. And then after the preamble and SFD will be the data. So the receiver will know after the SFD, it will be the data and it will start to read the data from like the third part, which is this part, and this part the actual quantum is 1, 2, 3, 4, 5 in here. Okay, so that's the thing. Let me find my pictures. Yeah, so you can also search online about the preamble and SFD, and you will get the same answer. So this part is preamble, and this part is SFD. And after these two is the data. So this is the task 1. So we know how to generate this spectrogram and signal file because we are using our own computer, and it doesn't allow us to send the signal to the outside, right? Because we don't have this kind of device. So we just use our own computer to as the receiver side. And yeah, but if you have your own device to send the signal, you can try. Also, if you can like transform this signal to the voice, it will also work. So you can play around with it if you have time. So let's assume we have already received the signal file, which is this one, signal file. So how can we, so as you can see, I read it in SIG here. So this one is the signals. So how can we process and read the content inside the signal? Then you can have a look of this script, load signal from file. So the first part of this script is to read the file. So you can see it called the library and run the read function. And then it saved the contents into SIG, right? And then here are some like parameters when we generate the file. This is the parameters. And then this one is the demodulation. So we need to demodulate the signal at first, and then we decode the contents after demodulation. So let's just copy this to code and see how it works. So because the parameter is the same, I don't need to type it into our command window. So I just copy the demodulation at first. And it print out some information. And then let's run the decoding part. As you can see, after the demodulation, and then we run the decoding stuff, and it can print out the information we have inside the message. So it's 1, 2, 3, 4, 5, and this 2 is the checksum, as we indicate in here. So in your report, you can just take a screenshot of this output to prove you have like you know how to generate and decode the signals. So that's the task 1 and task 2. But yeah, be careful is that we need to generate the message of 4336. So in the task 1, which is this file, you need to try to change this part. As you can see here, this one is just an array in string format. So you need to change to 4336 by yourself. So maybe you need to have a look of the syntax of MATLAB, but it will not be very hard. Try to write your own stuff in here. And then you add this line to generate the spectrogram. and put the spectrogram in your report. And of course, please remember to identify which part is preamble and which part is SFD and which part is the data in your report. And after that is to attach this signal file with your report so we can have a check of your file. So this is the task 1. And in the task 2 is pretty straightforward. Just use this script and run the demodulation and run the decoding. Then you will have an output of the decode. So you can see 1, 2, 3, 4, 5. So your output in here should be 4336. And the checksum is this. And just take a screenshot and put in your report, and it should be fine. And if you have time, you can also play around with the spreading factor. So you can try to change this one to another number and run it again. And you can see what is the difference between them. So this is the Lab7. This one is like pretty easy and straightforward. So you can try to do it right now. If you have any trouble, just let me know. And that's it. And just want to mention this one again. The next week, we will reschedule the tutorial from Wednesday to Thursday. So it's only for next week. So it's for Lab 8 next week. It will be on Thursday instead of Wednesday. Yeah, and please let me know if you have any trouble. You can try to do this lab right now so we can have a discussion if you have any kind of problem.
So is the message 4336 string, or do we have to encode the number?
Yeah, it must
Because
be a string.
it's in the quotation mark. So is it a string, or is it talking about the number 4336?
Yes, you can try to make an array of this number. It doesn't really matter. You can, as long as we can get it in the output. So the output in here could be 4336, like this one. This one should be 4336.
Oh, okay.
Okay, yeah. So, but it doesn't really matter if you can put it like together 4336 in one row. Is okay. Doesn't really matter.
Okay.
And the results for Lab 4 and 5 will be released very soon, probably this week. Yes, no problem. I think probably tomorrow. I will start the recording. So if you have any trouble, just you can share your screen.